Okay, let's solve two more very simple radical equations before we look at the recipe on how do you solve any radical equation. Well, here's the first one. It's very similar to one we had done in an earlier video, only this is the cube root of z. So if you have the cube root of z equal 3, how do I get z by itself on the left-hand side? In order to get rid of that radical, I have to raise both sides to the third power. So the third power cancels out the third root. And that gives us z equals, what is 3 cubed? 3 times 3 is 9, times 3 is 27. Yeah, and that tells us that the cube root of 27 is 3. All right, let's do one more. The cube root of y is negative 2. So when we take the cube root of y and we then cube both sides, or raise both sides to the third power, we get y all by itself on the left. And then what's negative 2 cubed? It's negative 2 times negative 2 times negative 2 would be negative 8. Okay, well, here is the recipe. And this recipe is a little more general. The recipe for solving radical equations containing nth roots, like this, which is a square root. So n would be 2, the second root. This would be the sixth root. This would be the fourth root. And here's an example that I'm going to do as we read through this recipe. Radical x plus 3 equals x minus 3. So what we have here is a square root, so the n would be 2 in this case. So step number 1 says isolate a single radical on one side of the equation. That's already done for us. And notice we haven't seen this yet, but we will in a few minutes. Your radical equations they're not limited to only one radical. We could have multiple, 2 or 3 radicals in one equation. This is saying just pick one of them, any one of them, and get it isolated on one side. We already have that. I'll write it again. X plus 3 under the radical equals x minus 3. Now, step 2, raise both sides to the n power. And that's going to eliminate this radical. And what n is for us is the 2, because this is the second root. So I'll use parentheses this time. This is step 2 I'm writing up here. So let's see. Now we just need to solve this. So the radical and the power of 2 cancel each other out. And that gives me an x plus 3 equals x minus 3 squared. Now don't relax here. Don't get lazy and say, oh, that's x squared minus 9. Absolutely not. We have to FOIL this out. X minus 3 times x minus 3. So here we get x plus 3 equals x minus 3 gives us x squared minus 6x plus 9, because we get minus 3x twice. If you wrote this out, x minus 3, the outer and inner would be negative 3x and negative 3x for negative 6x. So simplifying this, I'm going to subtract x and subtract 3 from both sides to get a 0 on the left. And this becomes x squared minus 7x plus 6. And let's see if we can factor that. Sure we can. X. It's got to be a minus and a minus because it has to multiply to positive 6 and add to a negative. So negative 1, negative 6, I think. Multiply them, you get positive 6. Add them, you get negative 7. Setting those equal to 0, we get x equals 1 and 6. Okay, now we're going to have to verify this. When we go, we're going to have to verify this works, each one of those. Because remember, at one point we squared both sides. So, coming back up to the top, let's just do the 6 first. If I plug in a 6, I would get radical 9, because 6 plus 3 equals, and 6 minus 3 is 3. Absolutely, that works. 6 works perfectly. Plugging in a 1, what do we get? If we plug in a 1, we get radical 4, because 1 plus 3 is equal to 1 minus 3. Absolutely does not work. Radical 4 is 2. 1 minus 3 is negative 2. So, and I have no problem on a test or homework, if you wrote down 1, 6 and then you went to verify and you found out the 1 doesn't work, just put a line through the x. I know exactly what you did. This says that x equals 6 is the only solution there is. All right, so we just checked our proposed solutions and we found out that 1 didn't work. This was a little easier than some of them we'll do in a few minutes. Number 3 says, if another radical remains, repeat steps 1 and 2. Every time you isolate a radical and then raise it up to the nth power, like squaring it, you get rid of one of the radicals. So eventually, if you have 2 or 3 radicals, eventually they're all going to go away. All right, let's continue with a few more before we finish this video. All right, number 12 says the cube root of w plus 2 is equal to 3. So what do I need to do to get the w plus 2 by itself? I need to raise both sides to the 3rd power. And that'll give us w plus 2 on the left equals 3 cubed is 27. Subtract 2 from both sides and we get w equals 25. Only one solution. And let's make sure that works in the original equation. 25 plus 2 is 27, and the cube root of 27 is indeed 3. So that's the correct answer. All right, now we're going to get a little tougher on the next couple, because these are the first examples where we have multiple radicals. But step 1 that says isolate one single radical on one side of the equation is already done for us here. On the left-hand side, we have one single radical all by itself. We don't on the right-hand side, but it doesn't matter. Just get one of them all by itself. And then what do? We square both sides to get rid of that radical. Don't forget, put parentheses around the entire right-hand side because this has to be FOILed out. You're squaring the left and you're squaring the right. All right, so let's go. I'm going to go to the right, make sure I have enough room here. If I square this, it just cancels out with the radical, and I get x plus 5 on the left. Now, maybe I'll go up here where I have some blank room and I'll use scratch paper. It might look a little confusing when you see this done if I don't write it out like this. Radical x plus 1 squared. Radical x plus 1, radical x plus 1. We have to FOIL it out. F-O-I-L. What is radical x times radical x? That's radical x squared, which is just x. That's like saying the square root of 10 times the square root of 10 would be the square root of 100, which is 10. Outer and inner are the same. It's radical x times 1, which is plus radical x, and then plus 1. So simplified, we would get x plus 2 radical x plus 1. That's going to be the right-hand side. So x plus 2 radical x plus 1. And now we're going to simplify this. Well, one nice and easy thing I notice right away is that both sides have an x. So if we subtract x from both sides, they're both gone. So if I take 2 radical x on the right and then subtract a 1 and subtract a 1, I get 2 radical x is equal to 4. Now from this point, I could divide both sides by 2, but I don't have to. If I have a radical that has a multiplier in front of it, just a nice real number, I can go ahead and square both sides. But when I do that, I need to remember, if I square, what do I get if I square this right-hand side? Well, squaring the radical x turns it into an x. Squaring the 2 would turn it into a 4. So maybe I'll just do it this way. Always works. Actually, both ways always work. As long as you don't make any mistakes and you follow the algebra rules, it will always work. That cancels. So that gives me that radical x is equal to 4 over 2, which is 2. I switched the order. I put the radical x on the left. Now one more time, have to square both sides, and I get x equals 4 when I square both of the sides. So I got only one solution. Let's verify, let's determine whether that actually works. When we plug it in to the original equation, I would get, I'm replacing the x with a 4. So that's the question we're asking. Is this left-hand side equal to the right-hand side? Radical 9 is 3 equals 2 plus 1 is 3. So this indeed is the solution. All right, we've got one more to do, and I hope I've got enough room for this. I'm going to go, let's see, maybe I'll go down and then start the other column here. I need to get one of these radicals by itself on one side. So I'm going to add this radical x minus 8 to both sides. And that's going to give me x minus 5 under the radical equals 3 plus radical x minus 8. All I did is add this radical, this thing, to both sides to get rid of it on the left and make it positive on the right. Now, square both sides. X minus 5 is equal to, that's easy, we squared this side, but now we got to square, remember, we got to square this, which means FOIL it out. So the first would be 3 times 3, which is 9. The outer and inner would be 3 times radical x minus 8. Both of them would be. So you got 2 of them. You have to double it to 6 radical x minus 8. And then the last would be this times itself. Radical x minus 8 times radical x minus 8 is what? X minus 8. So this might be the toughest part of the problem, just foiling this out. This again, I'll put the parentheses around. This is the last, this is the first, and this is the outer plus inner. Okay, so let's see what we get now. I can subtract x from both sides. I'm going to do just a little bit of simplifying here, or reducing. That x and that x are going away. I subtract x from both sides. And it gives me a negative 5 there. And now I'm going to combine the 9 and the negative 8. 9 minus 8 is 1. So now what we have is negative 5 equals 1 plus 6 times radical x minus 8. Maybe just to make sure I have enough room, I'm going to subtract 1 from both sides. And I'm going to squeeze it in here. Negative 6 equals 6 radical x minus 8. I'm writing very small down there. But now I'm going to get up right up here. So what do I do next? I could square both sides right now, or I could divide both sides by 6. I think that's the way I'm going to do it. That's truly isolating the radical. I could square both sides just like it is, but remember when you square this whole thing, you'd get 36 times x minus 8. So I'm going to divide both sides by 6. What do I get on the left when I divide both sides by 6? Negative 6 over 6 gives me negative 1 equals, and then I've just got radical x minus 8. I have a radical all by itself on one side. So what do? Square both sides to get rid of it. Squaring the left, maybe I'll remind ourselves what we're doing here. Squared, squared. And I'll get a 1 equals x minus 8. Add 8 to both sides. And we get x equals 9. Okay, so that's what we've come up with. Now, let's see if this works. Remember, we squared both sides, so I have to verify this. All right, is radical 9 minus 5 minus radical 9 minus 8 equal to 3? Well, this is radical 4. 9 minus 5 is 4, so that's 2 minus, I'm going to put a question mark over here. 9 minus 8 is 1. Radical 1 is 1. Is this true? Of course not. 1 is not equal to 3. So, x equals 9 failed when we plugged it in. So I'm going to write here the solution is the empty set. No solution. If you wrote this on a test or homework, this would be acceptable. As you computed, did all your arithmetic correct, and found out that 9 was a solution, but you plugged it in and it failed. So then you can just put a nice light X through it. Or you could simply go up here and say, no solution. Now, just one final comment. I'm not surprised at all that there was no solution because, let's see, when I think right back here, I could have detected it here before we squared both sides, and I could have detected it here as well. Remember what a radical means? It means the positive square root, the principal square root. It is never the case that, let me go this direction, that negative 1 could equal radical x minus 8. This is impossible, and that's what this says when you divide both sides by 6. This is impossible because this is the principal or positive square root. It can never equal negative 1. So at that point, I could have stopped and said, hey, wait a minute. This is not going to have a solution at all. But we went all the way through the end and discovered it anyways. So, solution, no solution.